One day, Ms. Sorensen assigned a project to build a cell model. That day in class, we had brainstormed ideas. There was the typical clay and styrofoam. Some people even went for cakes or using the game Minecraft. But I wanted to do something that had never been done before. I wanted to build a digital 3D model. I looked around on the internet and found Autodesk Maya, the first-class modeling software regularly sold around $3,500, was offered free to students. I jumped at the opportunity and proceeded to download it immediately. I originally started off dreaming big and looked around on the internet for ideas to kick me off. I had seen the picture shown on the left and imagined making something just as good, if not better. My lofty goals served me well, despite me sadly not meeting them. After repeatedly failing and deleting most of my progress, I finally had a product I was satisfied with. Maya was new software I had never used, and it was a big learning curve for me that I enjoyed a lot. Maya's toolbar includes around 5,000 options and inputs, so even changing the color of my model was a struggle, one I eventually lost, which is why it is all the same color. The project was a great experience for me, and using Maya was a lot of fun, despite taking me around 12 hours. And now we'll have Nick.
Thanks, Cole. Minecraft is a game based on placing blocks in survival. In the survival mode, you must gather all your resources and survive against the monsters that come out at night. It also has a creative mode that is a sandbox. This means that it is a free-form world that allows you to design and build without having to gather and collect resources. It is also possible to play Minecraft and to collaborate with other players via servers. Why would I use it for a cell model? I'm already decent at playing Minecraft, and I thought it would be more fun for me to build a digital model, and it would be a cool learning challenge. So I asked Ms. Sorensen if I could, and she said sure. Then she let the other 8th graders know they could do it too. I chose a plant cell because of its fixed, geometric, and blocky shape. I believe that Minecraft's blocks represent this well. This is a view from the side of my model. And now I have Philip.
Like Nick, I used Minecraft to make my cell model. I had decided I wanted to make an animal cell. Animal cells are more spherical than plant cells, which immediately caused a problem. In Minecraft, it is quite difficult and time-consuming to create a large sphere. So that things were a little easier, I started up a local host server that was running a few server plugins that would help with my building. Minecraft is written in a programming language called Java. This means that other people who know Java can write extensions to modify the game. This summer, I had learned to write some code that modified the game. Though I did not use any plugins that I wrote, with the plugins I used, it allowed me to create spheres, cylinders, and many other things. This helped me out immensely because it made the building go much faster. It was so easy to make these spheres that I shared a world file that had some spheres pre-made with Pete so that he could easily create his model as well. Even with this helpful tool, I still spent about 4 hours creating my cell model and the video that accompanied it. Now I would like to show a small video that I made that explains what I did a little bit more in detail.
In my project, I used Minecraft blocks to represent their functions in the real plant cell. The Minecraft materials I used to simulate the cell wall or membrane were glass for the cell wall and water for the cell membrane. I used glass for the cell wall because it is a rigid structure similar to the cell wall. I used water for the cell membrane because it is fluid. I also created a bow that would shoot flaming arrows. I used the flaming arrows to simulate viruses passing through the cell wall, but quickly would be stopped by the cell membrane. Another simulation I used was to create my Golgi apparatus out of redstone blocks. The purpose of redstone in the game is so that players have access to highly advanced logic-based wiring to set up cool mechanisms. The Golgi is an operating system that is similar to the FedEx of the cell. It takes in ribosomes, packages them, and sends them out to other organelles. Thank you. This shows the rough endoplasmic reticulum. It is rough because it has ribosomes on it. The function of the rough ER is it distributes proteins to the rest of the cell. I use this railroad track with a cart to represent the protein distribution process. Inside the cart are stakes to represent the proteins that are being distributed. Because I used Minecraft, I was able to show the movement of proteins throughout the cell by the endoplasmic reticulum. So the cart represents the distribution of the proteins being put out to the other organelles. Thank you.